Hello, hello, hey, hello everyone, welcome back to the channel. Today we will be taking a look at this question called the gifts order from the recent Codeforces round, which is Hello 2025. First of all, happy New Year to all of you, and let us read the question and try to solve it. So I definitely recommend, if you know how segment trees work, you can try this question on your own. And if you don't know how the segment tree works, uh, just hang with me. So the T generation has decided to purchase gifts for various needs. Thus, they have n different sweaters numbered from 1 to n. Okay, so if you want to skip the problem intro, there are timestamps uh, below the video, so you can directly jump to the solution. So yes, so the T generation has decided to purchase gifts for various needs. Thus they have n different sweaters numbered from 1 to n. The ith sweater has size AI, and now they need to send some sub-segment of sweaters to an Olympiad. It is necessary that the sweaters fit as many people as possible, but without having to take too many of them. So they need to choose two indices L and R to maximize convenience equal to, so maximum in that range minus minimum in that range minus size of that range minus 1. Okay, so basically the size of range is R minus L plus 1. So here they are just taking L R minus L. So that is the range of sizes minus the number of sweaters. So number of sweaters minus 1, right? Okay, so sometimes the sizes of sweaters change. It is known that there have been q changes. In each change, the size of the pth sweater becomes x. So help the T generation team and determine the maximum convenience among all possible pairs L, R initially as well as after each size change. So yes, inputs are n, which is the number of sweaters, q is queries, number of queries, a1 to an are the sizes of sweaters, and then q lines signify the updates. So let us take a look at this sample test case. Okay, yes, okay, and what are the corresponding answers? So 5 plus 1 is 6, 6 numbers from the bottom. Okay, so these are basically the answers. Let me clearly have a distinction. Okay, so what I can notice is that, okay, so suppose I am taking left limit as L. So in my final answer, after each update or before the first update, L comma R is generally my answer range. Okay, answer range in the sense, so uh, based on this range L comma R, I am calculating my answer, which is maximum in that range minus minimum in that range minus R minus L. Okay, so what I can notice is that, suppose there are suppose there will be one maximum, right? If maximum is somewhere in here and minimum is somewhere in here at index L1 and it is at index R1, so what I can notice is that instead of selecting L to R, I can just select L to 1, right? So I don't want this range, right, L to R, because my maximum minus minimum is staying same, but the size of my range, right, size of my range is decreasing here if I select L1 comma R1, having the boundaries, right? So minimum or maximum here, or maximum or minimum here. So what I can notice is that whenever I select L comma R as the range of my answer, I definitely know that minimum is sitting on L comma uh, if the minimum sitting is if the minimum is sitting on L, my maximum is definitely located at index R and vice versa, right? So if minimum is at R, my maximum is going to be sitting at index. Okay, maximum is going to be sitting at index L, right? So that is the key observation. So number one observation, right? So this is, I think you understand what is very important observation to solve this question. Okay, so this is basically the number one observation. So again, what I need to calculate? Suppose first case. First case. Okay, let's remain consistent with the colors. First case. So my minimum is located at, okay, my maximum is located at index R and my minimum is located at index L. So L is definitely less than R here. Okay, L stands for left and R stands for right here. And my number two case is, okay, we'll see what that is. So here my expression is going to be AR minus AL minus R minus L, isn't it? Yes. So I can I can rewrite this as AR minus R. Okay, can I write this AR minus R minus AL minus L, right? Okay. And what about the second case? Okay. What about second case? My maximum is sitting at L and my minimum is sitting at R. Okay, so here also L is less than R. Oh, okay, so here in this case, expression for my answer is going to be AL minus AR minus R minus L, right? So basically, you can rewrite this as AL plus L minus AR plus R. Okay, so okay, wait a minute. Okay, so yes, it's correct. You can rewrite this as AL plus L and minus AR plus R. So what I can notice is that, so basically this question can be solved using segment trees. Okay, this question can be solved using segment trees. I'll explain why. So okay, so what you can store in one node of segment tree. Okay, in one node of the segment tree, or you can say one index of the segment tree, as we generally refer segment trees as arrays. So let's refer it as node. So I will store ai plus I. Okay, I'll store ai plus I. I will store ai minus I. Okay, ai minus I. So minimum of ai minus I. Okay, okay, wait. Uh, ai minus I, and I need to store minimum of ai plus I in that range, as well as maximum of ai plus I in that range. Here also I need to store minimum of ai minus I in the range, whatever range the segment tree node has, and also maximum of ai minus I. So why I need to store that? Okay, you'll get to know quickly. So, and one more thing, we need to store answer as well. So answer based on the range in the segment tree. So let me quickly get these things. Okay, wait. Let me quickly get these things right down here, or maybe far than that. Yes, and let me increase size of that. Okay, so here we go. We start to build our segment tree. So here you will be having one node. Is it too big? Oh, I think so. So this is one node. Okay, this is it still the node. This is it still the node. Again, this one, this one, this thing, this thing. Okay, wait, let me draw the complete tree, and yes, we are done. Okay, yes, it is a bit screwed up. Okay, but nonetheless, uh, we should be able to visualize the things. So these things indicated in blue are segment tree indices, and these things indicated in red are the array indices. Okay, so what was I going to store in the each node? So let me copy that. Okay, where? Maybe here. Right. Okay, let me take this thing here, and okay, we should be fine. More fine. Right. So the numbers indicated in blue are the segment tree indices, and the numbers indicated in the red are just the array indices. Okay, so we also need these values, right? Okay, okay. uh, can I fit both of okay, everything? Wait, I'll fit it. Okay, and yes, I've got it, everything in one frame. So let's start building our segment tree. So at 0 comma 0, array in this array elements will be there, right? So array elements or the base elements, so you can say the base elements. Okay, so yes, and okay. So you know that indexing, we generally use in a zero based indexing in the segment trees. So but we have to make sure that while assigning the value to the nodes, we have to consider one based indexing in the array. Okay, so yes, so this is basically the index 1, 2, 3, 4, 5, 6, 7, and 8. So yes, here uh, in the leaf nodes, directly the values will be there, right? So minimum of ai plus I and maximum of ai plus I. So let me check how I've implemented that. So have I have implemented the struct related to the node. In that way only I'm going to tell my explanation. So go with my explanation. So maximum of segment of 2 star index plus 1 dot a. Okay, a is basically the maximum of ai plus I. Okay, so firstly we will store maximum of this, then we will store minimum of that. Okay, so let me change this. Firstly we'll store the maximum and we'll store minimum afterwards. So what about the minus thing? Also, the C is max, so yes, reversing these two as well. Maximum and then storing the minimum, and finally the answer related to that segment. Okay, yes. So 0 comma 0, ai plus I, so this is basically the 0th index. 7 plus 1, so value store will be 8. 8, can you see them? Okay, so value store would be 8. 8. Okay, I'll write answer, what you can say, out of this circle. Okay, so this fifth element of the node, I'll write it outside of the node. So what about ai minus I? So 7 minus 1 is 6. 6. And what is answer related to this node? So it is basically the 0, right? So if you can consider the index 1 to 1, then minimum will be the same, maximum will be the same, L will be the same as R. So our basically our answer is going to be 0. Okay, let me write answer in different color or not. Okay, no, 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 not needed. So what about this index? So 4 plus 2 is 6. 6, 2, 2. 2 plus 3 is 5. 5 minus 1 minus 1. 4 plus 4 is 8. 8, 0, 0. Okay. What about this fifth index? 8 plus 3 is 13. 13, 3 and 3. What about 5 means the sixth index in our original array. 8. 8 minus 4 minus 4. What about this? 8. 8 minus 6 minus 6. So basically 1 plus 7, 1 plus 7, 1 minus 7, 1 minus 7. 4 plus 8 is 12, 4 plus 8 is 12, 4 minus 8 is minus 4, and 4 minus 8 is minus 4. So while merging the nodes, okay, while merging the nodes, what I can notice is that how should I merge the nodes? So there will be two cases, right? So case 1. So in case 1, maximum is at right and minimum is at left. Okay. So in this case, we are dealing with this ai minus I thing, right? Ai minus I thing. So I want to ai minus I. Okay, not ai minus ai minus I. So basically, we are dealing with this thing, and as we know, L is less than R. So ar minus r should be taken as the first argument while doing the subtraction, and then secondly al minus l. So what I can notice is that if I'm merging these two nodes, so this is e1. Okay, I can draw these lot bigger, right? So oof, a1, b1, c1, d1 and e1, and a2, b2, c2, d2 and e2. So if I'm considering the case 1, so I have to consider ar minus r. So from right node I have to consider the second argument, right? Second argument. So if I consider the first case, then my answer can be b2 minus b1, right? So is it okay? b2 minus b1. ai minus I, right? So not b. Okay, not b. Definitely not b. Ai minus I we have stored at c comma d, right? So you have to take the maximum of these two, right? Maximum of ai minus I, so which is stored at c2, right? So it one of the candidates for my answer would be c2 minus d1, right? C2 minus d1. So basically this is for the first test case. Okay, first, not first test case, this it is for the first case. And if I consider this second case, then I know that my left node is contributing firstly. Okay, the first argument of my subtraction is coming from the left node, right? So I want to maximize that thing, right? So I will take the a1 and I want to minimize this thing, so I will take b2 from here. So another candidate for my answer is a1 minus b2. And and also these E1 E2 are also the candidates for my answer. Okay, so okay, yes, so these are also the candidates of my answer, right? So okay, again. Okay, good. So these E1 and E2 are also the candidates for my answer. So I will take maximum of all of these. I will take maximum of all of these and put it as the fifth argument of this merged node. Yes, makes sense, right? So the fifth argument would be basically the answer, and it will be the maximum of these four things. Okay, so that is basically the for merging the fifth component. What about the first thing? These two, a1 and a2, will directly take the maximum of these as the first argument. We will take the minimum of these as the second argument, right? So because I want to minimize the second value, right? So yes, and my third value is going to be the maximum of these two, so c1 and c2. My fourth value is going to be the minimum of d1 and d2, and that is how you keep on merging the nodes. Okay, that is how you keep on merging the nodes. Yes, so we'll try to do that here. So basically, see, answer for these all nodes is 0 first initially. Okay, so to merge this node, okay, so to merge this node, I will take the maximum of this a1 and a2, so it is basically 8. I will take minimum of these, so that's basically 6. I will take maximum of this, so that is again 6. I will take minimum of these two, that is 2. Okay, so I can zoom in a little bit so things are more clear. Yes. And what about the answer? So answer, there are four candidates to the answer, right? So c2 minus d1, so c2 minus d1, which will be minus 4. Okay, so minus 4, this is discarded as already I have better answer, right? 0 comma 0, this is discarded. uh, what about a1 minus b2? So a1 minus b2 is indeed 2, so it will surpass this 0, and answer for this node will be 2. So what does 2 signify? So basically, if I consider all the elements from this range 0 to 1 in my original array, so if I consider 7 and 4, what is the maximum answer that I can get? So if I consider only 7 comma 4, what is the maximum answer that I can get? So it is basically 7 minus 4 minus 2 minus 1, isn't it? Yes, it perfectly is. So 7 minus 3 is minus, okay, 7 minus 3 is 3, and 2 minus 1 is 1. So basically this is 2. So it is indeed correct. See, here also we got 2, right? So I'll show some more mergings as well. So uh, hold on with me. So 5 and 8, so you want to consider the maximum of those. It will be 5 here, it will be oh, okay, here it will be 8. And okay, so I think it will take a lot more time to merge this tree, so I will directly do it, and you can verify it on your own. Okay, so yes. Okay, tada. segment tree is built correctly, and you can notice that the first argument or the first number in the zeroth node of the segment tree holds the maximum value of ai plus I, which ai plus I, okay, y1 ai plus I, which occurs for this thing, right, which occur for 8 plus 5 here on the right side. Okay, I hope you are able to follow the pointer. And what about this thing? The minimum of ai plus I. So it occurs for this index. Okay. What about the maximum of ai minus I? So it occurs at this index, I believe. First index 7 and 1. What about minimum of ai minus I? So it occurs here 1 and minus 7, right? So basically segment tree is built properly, and this is basically the answer coming from all of these nodes. So basically, yes, my answer without any modification is 5, so it is correct, and I am going to perform one modification and leave others to you. So uh, definitely I definitely hope that you will be able to perform the other modifications as well. So it will be hands-on practice for you. So first modification, you okay, what's happening? Oh, so 1 and 2. So first modification is that on index 5 you modify the value to 4, right? So here you erase 8 and you keep 4, right? You keep 4 there. So let's head to our segment tree for the, what you can say, for updations, right? So fifth index. So in our segment tree, it is indicating the node 4 comma 4, right? 4 to 4. So here we want to do some changes. So yes, let's proceed. If we do, if we keep 4 in place of 8, so that will just become 4 and its index is 5. So what about ai plus I? So it won't be 13 anymore, it will be 9, and this ai minus I will be minus 1, so 9 and minus 1. Okay, 9, 9 minus 1 and minus 1. Okay, so we have to update these values also. So here in place of 13 it would be 9, right? So maximum of a1 and a2. What about minimum? So minimum is as it is 9. What about the maximum of these things? 3, okay, minus 1 and minus 4. So 3 is going to be erased, and there we will put minus 1. And yes, minus 4 remains as it is. And what about the answer? So basically previously answer was 5, but now answer is maximum of 0 comma 0. So 0 for this node, 0 for this node, and 1 for a1 minus a2, 9 minus 8, and a1 minus b2. Okay, sorry, a1 minus b2, a1 minus b2, 9 minus 8 is equal to 1, and c1 minus d2, right? So c2 minus d1, sorry, c2 minus d1, what am I doing? So c2 minus d1, minus 4 minus 1, minus 4 minus minus 1, so it will be minus 3. So basically my answer will be updated to 1. So is it correct? So for range 4 to 5, so means in the original indices 5 to 6, 5 to 6, so basically my values will be 4 and 2. So if I consider both of these values, my answer would be 4 minus 2 minus 2 minus 1. So which will be 2 minus 1 is equal to 1. Yes, indeed, this is built properly. So again, we have to merge these two nodes, right? So these two nodes we have to merge right now. And yes, so basically it will be 12. This will remain 8. This will change to -1, isn't it? Yes, it will. -1 and -6 will remain as it is. And what about our answer? So answer will be maximum of 2 comma 1. So basically these are two candidates, 2 comma 1, and a1 minus b2. So 9 minus 8 1, and c2 minus d1, I believe. Yeah, c2 minus d1. So c2 minus d1. Oh wait, this what is happening? What am I doing? Okay, c2 minus d1, right? So -4 minus 4, so it will be basically 0, right? Okay, -4 minus 4, right? So 0. So basically our answer is going to be modified to 2 here. Okay, all right. What about here? Merging these two nodes right now. Let's go. Here maximum will be 12, minimum will be 5. So maximum will be 12, minimum will be 5. And what about this thing? Maximum will remain 6 and minimum will remain -6, so no problems. And what are the candidates for answer? 3 comma 2 comma 8 minus 8 0, and -1 -1, so 0. So finally our answer will be updated to 3, right? Yep. So after one update my answer should be 3. Yes, indeed it is. Okay, bravo. So I definitely uh, highly recommend you to go through all of these updates. If you go through all of these updates and build your segment tree perfectly, then you will be the master of the segment trees, I believe. So yes, you can definitely try these updates on your own, and that is basically the logic. And after every update, or firstly after building, directly output the segment tree of 0. So basically uh, this value, right? So this value here is our answer after every update, and after building as well, so before any updates. Right, so segment tree of 0 is always our result. So we will directly head towards the code. So uh, defining the struct of node as these 5 values as mentioned in the solution. And yes, basically this is the template of the segment tree, nicely written. And uh, defining n globally, because this class needs to resize that to 4 star n. Yes, so inputting n, inputting q, so taking the input in the array, define, okay, initializing this segment tree with the n. So n, what does that mean? So it just resizes it to 4 star n. So yes, so it is the theory of segment tree that you won't need more than 4 into n nodes to build and whatever, do updates and get the answer. So you won't need more than 4 star n nodes if you have n elements in your array. So building that building our segment tree. So yes, fairly simple code, self-explanatory as well, because I have what you can say, I have explained it to you how to build it. You can go through all of these statements, so they are pretty easy to follow. And building, so before any queries, we have to query the segment tree. So query querying is just a lot simple, segment of 0 .e, so the answer related to whole interval, so whole array. And yes, inputting index value, and yes, doing index minus minus because our index segment tree is zero based indexing, based on the zero based indexing, and updating. Yes, you can fairly follow this update function as well. uh, it is well written, and I've explained it in the solution. Yes, and finally, for each query, output cout sg.query. So it will basically output the number present at the 0th node of the segment tree. And yes, finally, solution is complete. Happy New Year again to all. Hope you enjoyed solving this problem and listening to the solution as well, and yes, building the segment tree as well. Okay, I definitely hope you enjoyed that. And yes, so basically this is just some thoughts, random thoughts were going on my mind, in my mind. So I think this is the music, right? So that's the thing, one song. Anyways, so thank you for watching till here. Your attention span is, I really want to appreciate that, definitely. So thank you for watching the video till the end, I would say. Not just watching till the end. And if you liked it, definitely consider liking the video and staying subscribed to the channel, staying tuned to the channel. Okay, so thank you for watching. Thank you for watching completely. Thank you for watching again. Yes, so see you again, definitely.